Okay, welcome back everyone to another episode of the Global AI Podcast. I've been reminded just before this that we're on episode 19, which I'm very excited about because I tend to forget quite quickly because I think we just end up doing so many and it's like every other day. And anyway, very excited to have a very special guest today. But before that, let me introduce you to myself. My name's Akansha. If you've heard a few of the podcasts before, you've probably heard me talking and rambling before. I'm based in Melbourne, one of the AI MVPs out here in Australia. Let me introduce you to my co-host, Arafat.
Hi everyone, I'm Arafat Tessin. I'm also AI MVP based in Sydney, Australia. And I think we have the most amazing guest now because we have brought him from US. That's not quite common for us. So we have got Mark Hamilton, and I'll leave rest to the Mark to introduce himself. So over to you, Mark.
Awesome. Thanks for the great intro. Yeah, I'm Mark Hamilton. I'm a software engineer here on the Synapse Analytics team at Microsoft. I'm also a PhD student at MIT working in computer vision. And thanks so much for having me on the podcast today.
Oh my god! I knew like you worked at Synapse, and I purposefully sometimes like don't bother going through people's lives because I'm like, you can tell me on the podcast, and I can be amazingly surprised. That's amazing. Thank you for joining us with like your very precious time. Well, look, I think we'll dive straight into that, like what you just mentioned. I think it's interesting how few people actually understand machine learning in the first place. That's a whole separate podcast episode, I think, in and of itself. But if you want to talk a bit about Synapse, because you work on the product and stuff, and exactly what it does and what do you do within it, maybe.
Yeah, no, that's a great question. So to give sort of a really high level overview of what Synapse is, it's designed to make working with large amounts of data very simple. It's a place on Azure, Microsoft's cloud computing framework, to spin up very large clusters of computers and have them do work for you. So that's really Synapse in a nutshell. It's got tools to house your data, to work with your data, to run very large computational jobs on your data. And what I do in the Synapse Analytics team is I run an open source library called SynapseML. And this makes it very easy to run these large scale computing jobs on your databases and large data sets.
I think that's a very succinct way of explaining it, which I don't think I've heard yet. So thank you very much for that. And it makes such a difference, I think, in terms of like really quickly explaining a very big product, because I think it's an interesting move that Microsoft's made in terms of put everything into one place and you can do everything from the start, from like storing your data all the way to actually implementing some intelligence and making something out of your data at the same time. That's amazing to hear. It's all working together now. Is it actually being?
Yeah, there's definitely a lot of teams that are hacking on it. So I'm sure I glazed over a whole bunch of people's work, but sorry, teammates.
But I mean, I think at the end of the day, when people are trying to figure out what it is, it's kind of the explanation we need. So that helps out a little bit. But yeah, I guess in terms of the differences within using it, like why is this kind of becoming the industry standard of this is where you should go? Because it's, I mean, from my perspective, it's like it's because everything is in one place. Like, do you want to maybe talk about why people should use this in the first place?
Yeah, no, that's like a great question. I think a question that a lot of folks have when they're shopping for new technologies and things like this. Part of one of the things that makes Synapse a little bit different from other Azure resources, say like a VM or Azure Machine Learning, is that they try to make it a bit easier to get started, a bit easier to work with a large amount of computers, a large amount of storage and databases. If you were thinking about how would you figure out how to create a distributed computing system by yourself with Azure VMs, I mean, that's a lot of legwork. That's a lot of pain. And you got to run some other kind of distributed thing on top of these VMs. And so Synapse Analytics really wants to make this a lot simpler, a lot easier. So when you use Synapse Analytics, you'll be able to really quickly boot up a large cluster of machines, very quickly be able to code connected to that large cluster of machines. You can just have a nice little Jupyter notebook, which is kind of this very simple interface to put in code into distributed systems so that you can have a nice data science experience without really having to worry a lot about the infrastructure and the networking and the orchestration of these large clusters of computers. So that, I think, is really where Synapse Analytics shines, is that it makes this distributed computing workflow very simple, almost point and click.
That's nice. So yeah, so it means that it is solving the complex problems in a simpler way. I would put it at that this way. But just to go a little deeper into this, what tech stacks is it supporting? Like I'm a .NET developer, and I want everything to be run in that stack. It like being someone who has been working on .NET, and Microsoft has been promoting it for a while, and they have been working some fantastic work around it. Um, but there has always been um, a resistance or a friction when it comes to .NET supporting machine learning frameworks. Although Microsoft has done the product teams have done a great job, whether it is SDKs of cognitive services or ML.NET, and other frameworks like CNTK, but specifically Azure SynapseML, how is it supporting it?
Yeah, no, that's a great bunch of questions, and maybe I'll tackle sort of the first one first, which is you mentioned kind of what is the tech stack of Synapse?
Yeah.
What's actually going on under the hood? What sort of components are you working with? And so when I broadly say distributed computing, I mean a particular kind of distributed computing, which is Apache Spark. So Apache Spark kind of combines the distributed computing flavor of SQL and tables, joins, columns with the distributed computing flavor of Google's MapReduce. So, phrasing your computation as a bunch of maps on your data, a bunch of functional transformations of your data. And that's sort of more pioneered by Google and Hadoop. So Apache Spark kind of combines both of these into a nice framework that's simple, and it's usable from a wide variety of languages. So I think probably the default in Synapse is the PySpark, the Python variant of Apache Spark. But there's also one for Java and Scala. There's one for .NET, made by the Apache Spark for .NET team. And there's also language bindings and other things like R and Julia. Although I don't quite think Julia is supported in Synapse. I think R, .NET, Python, and Java Scala are the main ones that you can really work with. And what's nice about Spark is that it provides a lot of capabilities for you out of the box for doing joins and maps and reduces and sort of standard distributed computing style operations. But it also allows you to just inject your own code. So if you've got some Python code that you want to scale out, it's very easy to just inject that in to Apache Spark. If you've got some .NET code that you want to scale out, say like inference of an ML.NET model, it's fairly easy to kind of inject that into the Apache Spark framework. So although it's this one particular kind of distributed computing framework and it's got particular sorts of language bindings, it does give you a few escape hatches that you can really just take whatever you've been building in your language and shim it in there into an Apache Spark computation. And then I think your second question was more about what does the SynapseML library kind of bring to bear in this situation. And so as a really high level overview is that on top of Azure Synapse Analytics, we release an open source machine learning library called SynapseML that aims to make a whole bunch of different kinds of machine learning workflows very simple, like just like a few lines of code to kick off very large and complex machine learning workflows on that distributed Synapse cluster that we're building on top of. And so that's really where our team works the most, is taking different machine learning components from around the ecosystem and bringing them into our framework so that they all have the same look and feel. They're all 4 or 5 lines of code to create one of these machine learning experiments. And they all work on these very large distributed clusters so that you can be sure that when you've built your pipeline, you don't need to change it when you go to your massive customer data set or your tiny little laptop.
Yeah, that's a good suggestion, that we don't have to take a bigger systems, but we can just work with it with the smaller ones. You mentioned, Mark, and when we started about talking about taking the capabilities of Hadoop and others, and making it and combining them, and making it in a better way of as a Spark. I was just curious that how do we see, like, where is Hadoop standing right now? Because it was, when it came in the market, it was very famous, and now we have seen that people started talking about the Spark and other stuff. So just curious on that front. I know that it's not that Microsoft thing, but just from the market's perspective, where do you see that?
No, I mean, it's a super interesting field to sort of study. I view Spark as kind of Hadoop's um, spiritual successor in some ways, in that it really contains a lot of Hadoop at its core, except that there's a few, really nice things built on top of Hadoop. One of the key reasons that Hadoop has been, succeeded by Spark is that Hadoop requires every single MapReduce job you have to write down to disk. So if you want to do like a word count, you take all your documents, you map them to the document level word counts, write all those document level word counts to disk as like thousands of files. And then your reduce job reads all those and combines them. And so you have this big I/O problem, and I/O is the worst. I mean, nobody likes I/O. It causes like a 10x factor of performance hit. And really, what Spark aims to do is eliminate that whole need to ever go to disk until you're really done, until you've built your entire pipeline, and then the answer's there and you're ready to write to disk or something like this. So that's what Spark really adds on top of Hadoop. I mean, among other things, among like language bindings and things like this. But that's, I think, the core thing that Spark was made for, is to eliminate the need to constantly go back to disk, which allows you to make large, complex programs in a modular fashion, yet not have the pain of going to disk every 5 seconds. But the Spark ecosystem really, it kind of like grows out of the Hadoop ecosystem, and lots of stuff that Hadoop pioneered is still there. Like you've got HDFS, this like Hadoop file system, maybe the D in there, Hadoop distributed file system. Maybe that's what it stands for, but something like that. But this HDFS abstraction is like a beautiful way to read data from an arbitrary thing, whether it be your local file system, whether it be some large distributed file system, whether it be some cloud-based file system like Azure Storage. A lot of the APIs were sort of originally created in Hadoop land, but have since just become very useful even in Spark land, and projects further down like Flink and all the other things from that Apache Zoo they've got there.
Yeah, this is interesting to know, that what is going on under the hood, and you mentioned about the great I/O problem, and with Synapse Power as well. I think comes, there can be, like, there will be, or there are maybe that there are many challenges. So what do you think are the biggest challenges for SynapseML right now, or broadly as a piece of this technology? When, yes, we talked about IO, but is there anything other than that?
Yeah, so it's a great question and a great thing to think about. I think probably some of the biggest challenges with SynapseML derive from the layer underneath, derived from Apache Spark. If you've used Apache Spark, you might be very familiar with some of these trials and tribulations. But when it's not set up for you like Synapse, or you don't just use it right out of the box, it can be a little bit challenging to set up on your local set of machines, especially if you're not familiar with the Java and Scala side of the ecosystem. That, I think for developers that are coming from the Python ecosystem, some of this is just oh yeah, I don't want to have to deal with it. And I don't mean this in a pejorative way. I mean it really in a way of any good engineer should be thinking about, why do I need to deal with something that I don't absolutely need? So I think that that's a common reaction from a lot of Python developers, is that Spark it's a big system because it's designed to really scale to these very, very large workloads and a very diverse set of architectural components. And sometimes when you're just starting off in your project, you might not want to involve Spark yet. Even though we've tried to make things really easy and simple to start off with, if you're rolling your own Spark cluster, that can be quite a challenge. I think another existential challenge that the ecosystem faces is, really more of an extension of that previous one, which is that you need the JVM to run Spark. That the way that PySpark is built is that even though you're working in Python and you're using Python objects and you're running most of the time Python code, at the end of the day, there is some component of Spark that's running in Scala. And this can be frustrating for some folks, especially if you want the speed of native code and you want that identical memory sharing between your Python and your native layer. That Python has made so easy to do, and really accelerated frameworks like PyTorch and TensorFlow, which really heavily rely on this fact that there's not that much of a gap between the native layer and Python itself. So I think that this is one of these things that the ecosystem has tried to solve in a few different ways. There's a version of Spark that compiles down to native so that no JVM is needed. There's a project called Apache Arrow that standardizes Spark's memory so that it can be interoperable with the native layer. And hopefully some of these projects will grow and mature and give developers that ability to have a very thin stack while still maintaining a lot of the nice APIs and a lot of the nice generality of Spark. I think that's sort of one existential challenge for the ecosystem, I think.
That was very well thought through. Like, you have put some thought into these problems. I like that.
Oh yeah, I mean, we're dealing with them. We're responding to customers being like, "Why do I need this? Why do I don't need this?" All the time. So I think it's best to be forthcoming with these natural limitations of the Spark ecosystem, so that it's not, we're not snake oil salesmen over here.
And I think it's fair because I look at me like I love how you mentioned the tiny laptop part. I'm like, I downsized completely out of like my personal laptops and stuff. I was like, not spending that extra 2K. There's no need for it. And anytime I need to do anything, I'm just like, I'll just spin up a VM, or like I'll spin up Azure Machine Learning. I haven't gotten around to spinning up Synapse because I'm like, and this is going to lead into my next question of, I like that you talked about kind of like possibly a barrier of entry in terms of understanding this parallelization and all these different parts of it, especially with talking about Spark and Hadoop and all these different parts. People start hearing words and they're like, these, I know these, but like, what do I do with this? Like, this is not great. But the other aspect that I see, and this could be, I haven't fully used Synapse before. I will happily talk about that. But the pricing, that is the biggest conversation that tends to happen when I start talking about Synapse. Is there kind of real world examples, or is there even times have you got like areas you can talk about in terms of, hey, this is not a Synapse problem and you shouldn't look at Synapse at all. These are the times where you should, and these are some examples from maybe like real life partner times and use cases that you can talk about. And it's completely fair if you don't. Like, I don't expect you to know every single thing.
No, I mean, these are great tough questions here. I love them. Yeah, I think that maybe when you first start off in a project, you're trying to prototype something very quickly. You don't necessarily need the scale. You don't necessarily need the broad compatibility with different data storage layers. Sometimes it can be very useful to just spin up a little Python experiment and hack away and, have a nice little debug loop in PyCharm going. I think that, Synapse is really geared towards folks that are looking to systematize and organize and work with large data sets. I think those are sort of Synapse's primary customers. And of course, our team is always trying to make this easier so that we don't have any caveats there where, theoretically you can use Spark for small scale learning and it just, you get to parallelize over the cores on your machine. Although your there are other tools that give you that multi-core parallelism. You know, you can use Python multiprocessing. Things like PyTorch and NumPy have BLOS, so this basic linear algebra that's parallelized over the threads. So oftentimes these kinds of tools can get you that sort of speed up you're looking for. But when you really do need to execute something on a large amount of computers, that's, I think, where Synapse and the Apache Spark stack in general really shines. And I think also it's quite good for, you know, larger organizations, or really any size organization that's looking to give a lot of developers access to the same distributed resources and same data, with fine-grained ACLs to, you know, allow this person but not allow that troublemaker, you know. So I think that Synapse is really good for, you know, you as an owner of a large technological real estate to kind of organize and work with that, and share it in a live way with all of your employees at the same time.
That's a really well put through question, because I think, especially in Australia, like it's starting to come up a little bit, is what I see anyway. Maybe Arafat, you've seen it differently, but like Synapse is a conversation starter, and then it's like, oh, I don't know. And it's usually the unknowns of it, to be honest. Like, and that's kind of the area that I wanted to dig into. And I was like, this will be a great podcast, because I'm like, I want to know the bits that people don't talk about and people don't particularly understand. And this is actually very helpful. Yeah, and maybe, and it's also like, I mean, maybe you don't know, and that's completely fair to say that. Do you have some examples in terms of where Synapse is being implemented in some use cases? It's completely fair. I really don't expect you to know every person using Synapse on top of this. But if you did, that'd be really great to hear.
Yeah, so you know, Synapse itself gets used, I think, all over Microsoft these days. It's basically one of our premier ways to get an Apache Spark cluster that's completely managed for you. So really a lot of different large-scale products within Microsoft are based on Apache Spark and Synapse and SynapseML. Things like Bing. Bing has a huge amount of data. They need to do a lot of offline computation in addition to their online serving for web search and image search and all of their search and direction offerings. So they really heavily use Spark. LinkedIn is a really big Spark shop. They have almost all their code in Scala. They have these very large MapReduce jobs. They're certainly power users of the Apache Spark suite, and you know, we've certainly had a few collaborations with them. They've added this isolation forest anomaly detection system into our library, so that now anyone can use the LinkedIn isolation forest anomaly detection system that's used on LinkedIn to, you know, find bots, find fake news, find harmful and malicious content, these kinds of things. So those are a few of, I think, the big ones, and you know, a lot of different teams use Spark. I use it in my research to, you know, download zillions and zillions of things to make large data sets. Once you get the hang of it, you start using it all the time, because if you can just do something 100 times faster, you know, why not?
Yeah, that's absolutely interesting. And so there, we talked about about the real world examples, and we have been discussing the challenges and the other stuff, Mark. But what we first of all, there are two parts of this question. I would first love to know that where do you see, yes, it's good that Microsoft is using it, so this is something which really makes me happy as someone who has been working with a partner, so that if people ask us that what are the, where is it used, you know, when we talked about ml.net when it came out, and people started asking us that, oh, where it is used, we don't see any use cases. Then we started seeing the similar kind of friction, or I wouldn't say it's friction, it's a genuine question from customers, because if they want to implement, they should be knowing that who else is using it. So Microsoft being a biggest consumer of their own technologies is really cool. So I really like this, and that's why LinkedIn and Bing these are the very great examples. Like I never knew about this before this before this podcast. So thanks for sharing it. Now the question on that is that how, as us as someone who's being into the community as MVPs or as developers, or those who are not um, hardcore developers but they are keen on using this technology, how everybody from the community can contribute. Do you have any forums? Do you have any community lined up for that, or is there anything in the pipeline? Or if that's not, or is there any cool Discord channel, things like that? So please let us know.
Yeah, no, these are great questions. We're definitely always trying to kind of like grow our community presence in a scalable way, so that we can give the community a place to request features, ask questions, but without adding like more channels that we need to monitor because it's a little hard to monitor lots of different places. So I would definitely point folks to our website, which is aka.ms/spark, and maybe I'll stick this in the chat so that folks can visit it. Yeah, and so that will take us to our main website, where you'll be able to see lots of documentation and demos. You can try it out there. If you click on the GitHub link, probably in the top right of that web page, you'll get sent over to our GitHub. You can ask questions there. You can even try it out live in your browser. Preeti built this really nice integration with a tool called MyBinder, so that you can actually run this SynapseML notebooks and demos and experiments on your browser without any need for Synapse, without any need for a Spark cluster, without any need to install anything on your local machine. So I think that you'll spend a little time waiting for it to boot up the MyBinder instance, but then after that, you can feel free to party on in your cloud-backed, browser-enabled Spark cluster.
I think it's really funny that you talked about how when you're scaling out your marketing and stuff, it's like, oh, it must be scalable. And I'm like, oh, it's very on brand for the team, in fairness. I like that.
Yeah, I mean, I think that the challenge is that, when you build a product in Microsoft, you need to be everywhere all at once. You need to have connections with everyone and have language bindings in all different languages, but somehow find a way to do this without having a 60-person bloated org that actually supports this. So we've got a fairly small team of devoted folks that are building out this library, and our goal is always to grow in a way that won't incur too much maintenance costs, so that we can continue to grow, continue to add new features, continue to add new algorithms to the library and things like this.
Cool. And I think we covered almost most of, if not all, but almost everything from the Synapse aspect, Mark. From the community side, from the technicality side, from the stack side, from challenges and its real life use cases. Now, since we are at time, it will be my last question before we ask Akansha to make any comment on that. But there is something which I've been noticing since, like, not noticing. In fact, it was something popped up when you were working on Microsoft Art, Mark, and it really caught up the attention of everybody. So did mine as well. And I wanted to know that, I know that it is not related to Synapse ML, but I was quite interested to learn more about it. But just wanted to throw at you that what has been your favorite project when in Microsoft, and if you can also talk a little bit about of Microsoft Mosaic Art, so that people can know about it. And we will put all of those links in our YouTube description, and also, of course, within our audio podcast links.
Nice, lovely. Yeah, no, that art project we had a lot of fun with. For those that are listening, you might not be familiar. It's called Mosaic, and you can find it at aka.ms/mosaic. And so what this algorithm does is that it was work in conjunction with the Metropolitan Museum of Art, one of the largest art galleries in New York and in the United States. And they had this kind of key problem when COVID hit, which is that they had to close the doors. They could no longer accept visitors, and nobody could actually see the art that was inside the museum anymore. And so they really wanted to engage with the community in a way that was not have them visit New York and enter the museum. And so we wanted to build an experience that was engaging and fun and exciting, that used some new technologies and allowed people to really explore the collection at the Metropolitan Museum of Art. So what this algorithm does is that it looks through the collection of art in the Metropolitan Museum of Art, and it tries to find these hidden, uncannily similar pairs of artwork that are separated by thousands of years or are completely different genres or completely different media. So, you'd be able to take, a dress and ask what's the closest musical instrument to this dress, and you'd find a musical instrument with the same patterns and the same shape, just lying in a collection somewhere, because there's millions and millions of objects in this collection, from a really wide breadth of cultures and media and artists. So it was really fun. We were able to find lots of these pairs of artworks that, even though the artists never spoke to each other, the artists were in completely different geographical locales, they still shared a lot of the same characteristics. They looked the same. They meant similar things when you analyze them symbolically. And so we exposed this as a website that people can go and explore and find their own, fun pairs of artworks that are separated by these large chasms of time or genre. And we actually did use SynapseML to build this, which is like a fun little fact that you can read about it a little bit more on the GitHub README. But in particular, at the end of the day, like, we apply this new algorithm, this thing that finds these hidden pairs and matches, that was kind of developed in the PhD side of the world. And then once we find all these matches, we annotate every single object with lots and lots of these matches, and then write the whole mess to Azure Search. And for those of you who are not familiar with Azure Search, it's like making your own Google search, but with your own data. So that when you type in kind of the name of an object, you'll pull up that object, but you'll also pull up all the fields that you want to be associated with that object. And so in our case, it's all the different cross-cultural, cross-media matches. And what's nice is that it's real time. When you have all this data in your Azure Search account, it's fairly cheap. You don't need to have any large computers running. You just have this Azure Search instance running. And it's also real time, so that you can base a UX on top of it. And so that particular website is, just a little front end React client talking to an Azure Search Index. That Azure Search Index was populated via SynapseML, because we do all the heavy lifting, we do all the finding of these crazy pairs of artworks beforehand, and then blast it into this Azure Search Index using SynapseML. And yeah, so that was a really enjoyable project. We had a lot of fun. We worked with a great bunch of externs, which are kind of like interns, but even smaller time. They're there for like 4 weeks in the winter. So we worked with maybe 7 externs from MIT, and they really built a nice website out of this core research idea that we had. So that was certainly a good fun one. And then I think the other one of my favorite things is probably the first project I worked on at Microsoft, where we applied SynapseML to find snow leopards in camera trap imagery in the Himalayas, to get a better estimate of how many snow leopards there were in the Himalayas, because there's actually like a large academic controversy where a main snow leopard conservation group, they just said snow leopards are no longer endangered, because they twiddled the parameters of a given statistical model and said, oh, they're no longer endangered, which is not good for snow leopards at the end of the day. It just means they lose a lot of their protections. And so the Snow Leopard Trust, a small nonprofit, was sort of opposed to this ruling, and really set out to try to do much broader surveys Yeah, and we work with them to kind of process like millions of their images and detect leopards in their camera trap data, and started a really nice collaboration. We got to go to Kyrgyzstan to visit them and see the camera traps and stuff like that, and that certainly will always be in my heart as one of my favorite like fun research projects through this library.
Okay, well, I was already impressed. Didn't need that extra little bit there, Mark. Not gonna lie. Like now I'm just like, this is amazing. This is all I wanted to see in this. But I think it's like, I mean, I knew about the Met and like the fact that they'd like put it all up kind of as a virtual thing. Didn't realize there was like so much nuance to this. And now I'm like, yes, I don't have any plans to go to New York anytime soon. So I'm gonna go check that out later today. That's actually amazing. And the snow leopard, oh, that's amazing. We've done something similar down here actually in Australia, like the Tassie Devil project, where it's very similarly identifying whether Tassie Devils have facial tumor, which is endemic to them. But I think it's such an interesting use case in terms of actual AI for good, which is really, really nice to hear. And I think it's a perfect note to wrap up this podcast episode on. Some goodness in the world. I like it. It's a perfect way to wrap it up. Thank you so much for your time. I think we are very appreciative of it. It is very limited time and we appreciate any little minute, and you've given us a fair bit of it. So thank you so much for your time. Thank you so much for coming and sharing everything you worked on, everything you're building at the moment. We're really excited to see where it all goes.
Well, thank you so much for having me. I mean, it's been a ton of fun to chat with you guys. Yeah, some awesome, difficult, and fun questions, and we really appreciate it. And really enjoyed the experience, and very happy to share our work with a broader community.
No, this is great. Those tough questions help me answer the tough questions here. So I'm like, oh, you're making my life easier. I'm going to put it on someone else. But no, thank you so much. We'll wrap it off there, folks. We'll be back again next month with episode 20. So stay tuned and we'll see you then. Take care.
All right. Bye-bye.